Routing and Switching Introduction to Network, CCNA Level 1, Chapter 1, Exploring the Network. This chapter introduces a platform of data networks upon which our social and business relationships increasingly depend. The material lays the groundwork for exploring the services, technology, and issues encountered by network professionals as they design, build, and maintain the modern network. Chapter 1 covers the following part: globally connected, LAN, WANs, and the Internet, the network as a platform, the changing network environment. Imagine a world without the Internet. No more Google, YouTube, instant messaging, Facebook, Wikipedia, online gaming. No more price comparison websites, avoiding lines by shopping online, or quickly looking up phone numbers. How different would our life be without all of this? That was the world we lived in just 15 to 20 years ago. But over the years, data networks have slowly expanded and been repurposed to improve the quality of life for people everywhere. In the course of a day, resources that are available through the Internet can help you post and share your photograph, home videos, access and submit schoolwork, communicate with friends, family, watch videos, movies or television on demand, play online games with friends, decide what to wear using online current weather conditions, find the least congested route to your destination displaying weather and traffic video from webcams, check your bank balance, and pay bill electronically. The Internet has changed the manner in which social, commercial, political, and personal interactions occur. The immediate nature of communication over the Internet encourages the creation of global community. The global community allows for social interaction that is independent of location or time zone. The creation of online community for the exchange of ideas and information has the potential to increase productivity opportunities across the globe. Cisco refers to this as the human network. Network and the Internet have changed everything we do, from the way we learn, to the way we communicate, to how we work, and even how we play. Networks have changed the way we learn. Robust and reliable networks support and enrich student learning experiences. They deliver learning material in a wide range of formats, including interactive activities, assessment, and feedback. Networks now support the creation of virtual classrooms, provide on-demand video, enable collaborative learning spaces, enable mobile learning. Access to high-quality instruction is no longer restricted to students living in proximity to where that instruction is being delivered. The globalization of the Internet has ushered in new forms of communication that empower individuals to create information that can be accessed by a global audience. Some forms of communication include instant messaging, texting, social media, collaboration tools, web blogs or blogs, wikis, podcasting, peer-to-peer file sharing. In the business world, data networks were initially used by businesses to internally record and manage financial information, customer information, and employee payroll systems. These business networks evolved to enable the transmission of many different types of information services, including email, video, messaging, and telephony. The widespread adoption of the Internet by the entertainment and travel industries enhances the ability to enjoy and share many forms of recreation regardless of location. It is possible to explore places interactively that previously we could only dream of visiting, as well as preview the actual destinations before making a trip. Travelers can post the details and photographs from their adventures online for others to view. Network enables the creation of new forms of entertainment such as online games. Players participate in any kind of online competition that game designer can imagine. Networks come in all sizes. They can range from simple networks consisting of 2 computers to networks connecting millions of devices. Small home networks connect a few computers to each other and the Internet. The small office, home office, or Soho network enables computers within a home office or a remote office to connect to a corporate network or access to centralized shared resources. Medium to large networks, such as those used by corporations and schools, can have many locations with hundreds or thousands of interconnected computers. The Internet is a network of networks that connect hundreds of millions of computers worldwide. All computers connected to a network that participate directly in network communication are classified as hosts or end devices. Hosts can send and receive messages on the network. In modern networks, end devices can act as a client, a server, or both. The software installed on the computers determines which role the computer plays. Servers are hosts that have software installed that enables them to provide information like email, web page to other hosts on the network. Clients are computer hosts that have software installed that enables them to request and display the information obtained from the server. A computer with server software can provide services simultaneously to one or many clients. Client and server software usually runs on separate computers, but it is also possible for one computer to carry out both roles at the same time. In small businesses and homes, many computers function as the servers and clients on the network. This type of network is called a peer-to-peer network. The simplest peer-to-peer network consists of two directly connected computers using a wired or wireless connection as shown in the figure. The advantages are easy to set up, less complexity, lower cost, can be used for simple tasks such as transferring files and sharing printers. The disadvantages are no centralized administration, not as secure, not scalable, all devices may act as both client and servers, which can slow their performance. The network infrastructure contains three categories of network components: devices, media, and services. Devices can be split into two parts: end devices and intermediary devices. Examples of end devices are computers, network printers, voice over IP phone, telepresence endpoint, security camera, mobile handheld devices. Examples of intermediary network devices are network access devices like switches and wireless access point, internetworking devices like routers, and security devices like firewalls. Modern networks mainly use three types of media to interconnect devices and to provide the pathway over which data can be transmitted. As shown in the figure, these media are metallic wires within cables, glass or plastic fibers for fiber optic cable, wireless transmission. It is helpful to use visual representations when conveying complex information, such as displaying all the devices and medium in a large internetwork. As for end devices, we have computer, IP phone, laptop, wireless tablet, printer, telepresence endpoint. For intermediary device, we have the wireless router, the multi-layer switch, a LAN switch, a router, and firewall appliance. For network media, we have the wireless media, we have the LAN media, and we have the WAN media. Topology diagrams are mandatory for anyone working with a network. It provides a visual map of how the network is connected. There are two types of topology diagram. The physical topology diagram, which identifies the physical location of intermediary devices, configured port, and cable installation. The logical topology diagram, which identifies devices, port, and IP addressing scheme. The two most common types of network infrastructure are the local area network or LAN, the wide area network or WAN. Other types of network include the metropolitan area network, which is the MAN, the wireless local area network or WLAN, the storage area network or SAN. Local area network is a network infrastructure that provides access to users and end devices in a small geographical area, such as a home, school, office building, or campus. LAN is usually administered by a single organization or individual. LAN provides high-speed bandwidth to internal end devices and intermediary devices. Wide area network is a network infrastructure that provides access to other networks over a wide geographical area. WANs are typically managed by service providers or internet service providers. Specific features of WANs include WANs interconnect LANs over wide geographical areas such as between cities, states, provinces, countries, or continents. WANs are usually administered by multiple service providers. WANs typically provide slower speed links between LANs. The Internet is a worldwide collection of interconnected networks cooperating with each other to exchange information using common standards. The Internet is a corporation of networks and is not owned by any individual or group. There are two other terms which are similar to the term Internet: Intranet and Extranet. Intranet is a term often used to refer to a private connection of LANs and WANs that belong to an organization and is designed to be accessible only by the organization's member, employee, or others with authorization. Intranet are basically an Internet which is usually only accessible from within the organization. An organization may use an extranet to provide secure and safe access to individuals who work for different organizations but require company data. For example, a company providing access to outside suppliers or contractors. There are many different ways to connect users and organizations to the Internet. The popular choices include broadband cable, broadband digital subscriber line or DSL, wireless WANs, and mobile services. The figure illustrates common connection options for small office and home office users, which include cable, DSL, cellular, satellite, dial-up telephone. Corporate connection options differ from home user options. The common connection options for organizations include dedicated lease lines, Metro Ethernet, DSL, satellite. Modern networks are constantly evolving to meet user demands. Traditional telephone, radio, and television networks were maintained separately from data networks. In the past, every one of these services required a dedicated network with different communication channels and different technology to carry a particular communication signal. Each service had its own set of rules and standards to ensure successful communication. Advances in technology are enabling us to consolidate these different kinds of networks onto one platform referred to as a converged network. Unlike dedicated networks, converged networks are capable of delivering voice, video streams, text, and graphic between many different types of devices over the same communication channel and network structure, as shown in the figure. The conversion of the different types of communication networks onto one platform represents the first phase in building the intelligent information network. The next phase will be to consolidate not only the different types of messages onto a single network, but to also consolidate the applications that generate, transmit, and secure the messages onto integrated network devices. As network evolve, we are discovering that there are four basic characteristics that the underlying architecture needs to address in order to meet user expectations. Fault tolerance. Redundant connections are needed to allow alternative paths if a device or a link fails. Scalability. Additional users and whole networks can be connected to the Internet without degrading performance for existing users. Quality of service should ensure that priorities are matched with the type of communication and its importance to the organization. For example, streaming media will need high priority while web pages will need lower priority. Security. The network should be protected with software and hardware security, and physical access to network devices should be prevented. In the circuit switch connection-oriented network, when a person made a call using a traditional telephone set, the call first went through a setup process. This process identified the telephone switching locations between the person making the call, the source, and the phone set receiving the call, the destination. A temporary path or circuit was created for the duration of the telephone call. If any link or device in the circuit failed, the call was dropped. To reconnect, a new call had to be made with a new circuit. This connection process is referred to as the circuit switch process and is illustrated in the figure. After a circuit is established, even if no communication is occurring between the person on either end of the call, the circuit remains connected and resources used until one of the parties disconnects the call. However, packet switch connectionless network is a more fault-tolerant network. The principle for this type of network is that a single message can be broken into multiple message blocks, with each message block containing addressing information to indicate the origination point and the final destination. Using this embedded information, these message blocks, called packets, can be sent through the network along various paths, and can be reassembled into the original message when reaching their destination, as illustrated in the figure. Each packet is sent independently from one location to another. At each location, a routing decision is made as to which path to use to forward the packet toward its final destination. If a previously used path is no longer available, the routing function can dynamically choose the next best available path. The need for a single, reserved circuit from end to end does not exist in a packet switch network. By providing a method to dynamically use redundant paths without intervention by the user, the Internet has become a fault-tolerant method of communication. A scalable network can expand quickly to support new users and applications without impacting the performance of the services being delivered to existing users. Quality of service is also an ever-increasing requirement of networks today. New applications available to users over internetworks, such as voice and live video transmission, create a higher expectations for the quality of delivered services. Achieving the required quality of service by managing the delay and packet loss parameters on a network becomes the secret to a successful end-to-end application quality solution. One way this can be accomplished is through classification. For example, communication that is time-sensitive, such as voice transmission, would be classified differently from communication that can tolerate delay, such as file transfer. There are two types of network security concern that must be addressed: network infrastructure security and information security. Network infrastructure security includes the physical securing of devices that provide network connectivity and preventing unauthorized access to the management software that reside on them. Information security refers to protecting the information contained within the packet being transmitted over the network and the information stored on network-attached devices. Security measures taken in a network should prevent unauthorized disclosure, prevent theft of information, prevent unauthorized modification of information, prevent denial of service. In order to achieve the goals of network security, there are three primary requirements: ensure confidentiality, maintain communication integrity, and ensure availability. Some of the new networking trends: bring your own device, online collaboration, video, cloud computing. Bring your own device, BYOD, is about end users having the freedom to use personal tools to access information and communicate across a business or campus network. Bring your own device means any device with any ownership used anywhere. Individuals want to connect to the network not only for access to data application, but also to collaborate with one another. Collaboration is defined as the act of working with another or others on a joint project. Collaboration tools give employees, students, teachers, customers, and partners a way to instantly connect, interact, and conduct business through whatever communication channels they prefer and achieve their objective. Video is another trend in networking that is critical in the communication and collaboration effort. Video is being used for communication, collaboration, and entertainment. Video is a useful tool for conducting business at a distance, both locally and globally. Video helps businesses create a competitive advantage, lower costs, reduce the impact on the environment by reducing the need to travel. Cloud computing is another global trend changing the way we access and store data. Cloud computing is the use of computing resources, hardware and software, that are delivered as a service over a network. Cloud computing allows us to store personal files, even backup our entire hard disk drive on servers over the Internet. Applications such as word processing and photo editing can also be accessed using the cloud. Cloud computing offers the following potential benefits: organizational flexibility, agility and rapid deployment, reduced cost of infrastructure, refocus of IT resources, creation of new business models. There are four primary types of cloud: public cloud, private cloud, custom cloud, and hybrid cloud. A data center is a facility used to house computer systems and associated components including redundant data communication connections, high-speed virtual servers, redundant storage systems, redundant or backup power supplies, environmental control, security devices. Networking trends are not only affecting the way we communicate at work and at school, they are also changing just about every aspect of the home. The newest home trends include smart home technology. Smart home technology is technology that is integrated into everyday appliances, allowing them to interconnect with other devices, making them more smart or automated. Powerline networking is an emerging trend for home networking that uses existing electrical wiring to connect devices as shown in the figure. The concept of no new wires means the ability to connect the devices to the network wherever there is an electrical outlet. The benefits are: save the cost of installing data cables, no additional cost to the electrical bill. Using the same wiring that deliver electricity, Powerline networking sends information by sending data on certain frequencies, similar to the same technology used for DSL. Wireless Internet Service Provider is an ISP that connects subscribers to a designated access point or hotspot using similar wireless technology found in home wireless local area network. And they are commonly found in rural environments where DSL or cable services are not available. Wireless broadband is another wireless solution for the home and small businesses. This uses the same cellular technology used to access the internet with smartphone or tablet. An antenna is installed outside the house, providing either wireless or wired connectivity for devices in the home. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or as large as a corporation with thousands of users. Securing a network involves protocols, technology, devices, tools, and techniques to secure data and reduce threats. Many external network security threats today are spread over the internet. These include viruses, worms, Trojan horses, spyware and adware, zero-day attack, hacker attacks, denial of service attacks, data interception and theft, identity theft. It is equally important to consider internal threats. There have been many studies that show that the most common data breaches happen because of internal users of the network. Network security should include antivirus and anti-spyware, firewall filtering, dedicated firewall systems, access control lists, intrusion prevention systems, virtual private networks. The network architecture refers to the devices, connections, and products that are integrated to support the necessary technologies and applications. A well-planned network technology architecture helps ensure the connection of any device across any combination of networks. While ensuring connectivity, it also increases cost efficiency by integrating network security and management and improves business processes. Building networks that support our trend of today and the need and trend of the future start with a clear understanding of the underlying switching and routing infrastructure. Achieving Cisco Certified Network Associate Certification (CCNA) is the first step in helping an individual prepare for a career in networking. CCNA certification validates an individual's ability to install, configure, operate, and troubleshoot medium-sized route and switch networks, including implementation and verification of connection to a remote site in a WAN. In this chapter we saw that networks and the internet have changed the way we communicate, learn, work, and even play, that networks come in all sizes, that the internet is the largest network in existence. We also saw that the network infrastructure is the platform that supports the network, that networks must be reliable, that network security is an integral part of computer networking. Finally, we saw that network infrastructure can vary greatly in terms of size, number of users, and number and type of services.